Hello and welcome to another session in the Food Packaging Technology course. We are on week 6 and we were discussing on the different advances in packaging technology. We talked about active packaging, modified, atmospheric and aseptic packaging. In the last class we dealt with a very important topic which is bioplastics, and today we'll be continuing with the same portion as it's very important in today's settings. We'll be talking mostly on edible coatings, edible gums, and how these can be a part of the food packaging industry. This is a picture that is taken from the particular source. Now, edible packaging consists of edible films, sheets, coats, or pouches. Just like your bioplastic form polymers, these are edible. You can actually consume them. Biodegradable polymers, which could be degraded easily in nature. Edible packaging, it can even be consumed without any harmful effects. At the same time, it has a protective or a barrier properties which would give an additional protection to the food. Now, edible films, if you say, they have the thickness less than 254 micrometers. On the other hand, edible sheets, when you call them a sheet, the thickness is greater than 254 micrometer. You've got another structure which is known as pouches or edible pouches or standalone structures, and they are preformed separately and the food is placed in them. Another type is the edible coatings, which are thin layers of edible materials which are directly added onto the food substances. So these are the different forms in which these edible packaging can be made: films, sheets, coatings and pouches. Now the edible films and coatings, they are again just like your biodegradable films. They are based on proteins, polysaccharides and lipids. And these have a potential to increase the food quality and they can replace the food packaging requirements. Edible films are maybe as coats or the food may be placed in them. And they might be limitations of migration of moisture, flavor, colors. So they might not be as great as your normal thermoplastics, but they are a good replacement to a great extent. Now these are again pictures. This is your edible film which can be of different colors, or your edible coatings which can be on different sweets, which can be consumed as a part of the food, but at the same time it can increase the shelf life and the quality of the food. Now what is the advantage of these edible films? As is evident, you can imagine having your burgers or your sweets with the package. It sounds gross, but it's actually going to help in the way that there is no disposable problem if you consume it along with the packaged product. So it's going to be eco-friendly. It can be produced exclusively from renewable edible ingredients, like I told you, polysaccharides or proteins or lipids. And it's anticipated to degrade readily than your normal plastics. You can increase the organoleptic properties, that's your sensory properties of the packaged product by providing color, flavor and sweetness to the package itself. You can supplement the nutritional value of the food by adding those nutritional supplements to the package. It can be applied inside the heterogeneous food at the interface between different layers or components. Another important advantage, it can be tailored to prevent deteriorative intercomponent moisture and solute migration. My edible package will act as a barrier so that the outer package no migration will take place from the outer package into your food. So it's like an extra barrier, especially in foods like pizzas and pies and candies. It can function as a carrier from antimicrobial and antioxidant agents. So instead of adding these into your food, you can actually add it to your edible packages. These edible coatings can either be consumed or it can be disposed, whatever. That is the choice of the consumer, but actually it can function as a carrier for these kind of extra nutrients. It can control the diffusion rate of the preservative substances from the surface to the interior of the food and can be used as a microencapsulation of food flavorings. So microencapsulation is one of the latest technologies. So these food flavorings, they can be directly added onto these edible coatings so that the first taste or sense that you get is of these flavors. Okay, you get that burst of these flavors in your mouth when you bite into them. What are the requirements for the edible films or the coating? Number one, most important, they should prevent product dehydration. They should control the transmission of gases and vapors and solutes, from the loss of flavor, nor ingress of flavor from outside. They should provide mechanical protection to the food from damage by squeezing or compression. They should prevent that. They should restrict microbial invasion, which is a very important property. They should have good mechanical properties. They should serve as a carrier for additives like antioxidants, antimicrobial agents, flavors or colors. And the composition should conform to the regulation that apply to the food, which is the most important thing. There are regulations for the foods. You cannot comply to the regulations of food at the same time not have those regulations met by the edible coatings. The edible coatings must conform to all the regulations that apply to those food in which it is to be wrapped. Now, the materials for edible packaging. You have polysaccharides, and under polysaccharides you can use starch, cellulose, hemicellulose, chitosan, gums. Very similar to your biodegradable plastics. And you can have lipids and proteins. Let's look at these one by one. Just like your biodegradable polymers, starch, edible starch films and coatings are mainly used in your bakeries, confectioneries, batters and meat products. If you recall, starch is made of amylose and amylopectin. And because amylose has got a linear nature, it forms a coherent, relatively strong freestanding film. On the other hand, amylopectin is more branched. So the film that you get from that is usually brittle and non-continuous. So it's more easier to get a continuous, strong film from amylose rather than from amylopectin. And to increase the water solubility, partial esterification of the high amylose starch with propylene oxide can be done. And this will give you hydroxypopulated derivatives. These high amylose starch and the hydroxypropylated high amylose starch, all these can be used as edible coatings on foods. It can be used as encapsulating agents to provide oxygen and a lipid barrier and to improve the appearance, texture and handling. So starch is very important edible packaging, and it can be modified to improve its property as an edible coating. Cellulose is another edible film that can be used. Numerous hydroxyl functions in the cellulose resulting in strong hydrogen bonds. It creates a physical network that makes the material non-fusible. So cellulose is insoluble in aqueous solution. And to produce plastic materials from cellulose, a chemical modification has to be done. There is one way that you can use cellulose as an edible coating. The most common cellulose ethers are methyl cellulose, which is known as MC, hydroxymethyl cellulose, hydroxypropyl methyl cellulose, and the most common carboxymethyl cellulose. All of these have got very good film properties, and your methyl cellulose are excellent film making properties as well as high solubility, and they've got, more important, the efficient oxygen and lipid barrier. So both oxygen and lipid barrier is important because you do not want the lipids to ooze out from the food into the package. And so this acts as a very good oxygen as well as lipid barrier. Coming to hemicellulose, which can be used as an edible film, there have been a number of studies on hemicellulose for edible food coatings based on beta-glucan extracts from barley, hulless barley and oats, and even from corn hull. See, xylans from birchwood, from grass and from corn cob. These have been used as an additive in wheat gluten, and this helps to form an edible composite film. So these xylans can be used along with has been used to be making a lot of edible coatings. Chitosan, we saw the same thing when you talked about biodegradable plastics. Chitin, after cellulose, is one of the most abundantly used polysaccharide based edible coatings. Especially they are abundant in your exoskeletons or the shells of arthropods and the cell walls of insect cuticles. So what is the effect of chitosan coating on the shelf life of fresh cut fruits and vegetables? They have found that they have got a very good or a positive effect on the shelf life of strawberries, carrots, mangoes, cantaloupe, mushrooms. And in all these cases, because I told you chitosan has antimicrobial properties, so all these cases microbial growth has been inhibited and shelf life has increased. Gums, very important. The alginates which have been extracted from brown seaweeds of the Phaeophycean family they are actually the salts of alginic acid, and this is a linear copolymer of D-manuronic acid and L-guluronic acid monomers. So films that are produced by the evaporation of water from a thin layer of this alginate solution, They're impervious to oil and grease. They're lipid barrier. They've got good barrier against oxygen, but they have high water vapor permeability, and that is a problem. It's not a good barrier against water, but it is a good lipid and oxygen barrier. Carrageenan is another gum other than alginates that has been applied to a variety of foods, and these can help to carry antimicrobials and to reduce moisture loss, oxidation and disintegration. Agar is another gum also that comes under this category. These agar form strong gels that are characterized by melting points which are much higher than the initial gelation temperature. So agar coatings containing water soluble antibiotics and bacteriocin have been used on flesh foods. So gums including alginates, carrageenan and your agar, they're excellent as edible gums or coatings. Now these are some of the commonly used polysaccharide based hydrocolloids, and these are the main characteristics taken from this paper. Chitosan, sodium alginate, starch, cellulose, pectin. So all of these polysaccharides, chitosan, are from exoskeletons. Their packaging characteristic is they're soluble in weak acids, good barrier against oxygen and carbon dioxide. But they're hydrophilic. We have mentioned this. Sodium alginate produced by and refined from various brown algae or from the bacteria as exopolysaccharides. Now these are very soluble in water and they tend to form lumps with insufficient shear. Okay, they form gels in the presence of cations. They have low tensile strength. It's not really used. Starch is very important. It's isolated from plant roots, stalks, crop seeds. They have got tensile properties that are suitable for the production of packaging material. That's why I said starch is an important polysaccharide. Cellulose, again, made isolated from plant cells, great foaming properties, increased solubility in organic solvents, and they're also a good gas barrier in low moisture environment. Coming to pectin, which is another polysaccharide from plants, they've got great gelling properties, hydrophilic property. It has a tendency to form gel in acidic conditions. But the problem is they have got poor water vapor barrier and low mechanical properties. So some of the common ones, chitosan and starch, are some of the popular edible coatings from polysaccharides. Coming to lipids. Now lipids is another class of edible films that can be prepared. Lipids like bee waxes, your rice bran, your paraffin wax, acetylated monoglycerides, etc. These have been used for making films. Wax has been used to coat your cottage cheese and fruits, etc. You must have seen how these fruits are exported with these lipids or these wax around it. Prevents dehydration, keeps the shelf life better, quality better. Now lipids are hydrophobic and therefore they will be a good moisture barrier. But however, their mechanical barrier is inferior to proteins and polysaccharides. So if you want to make a good water vapor barrier, your lipids is a good choice. But actually compared to your proteins and polysaccharides, their mechanical properties are much inferior. Proteins, another class of edible films. The first one among them and the most popular is your wheat protein. Now wheat protein films are brittle because of the excessive intermolecular force. So here you require plasticizers that will reduce the force and will increase the mobility, or that makes it more flexible. Chains become more flexible when you have the plasticizers between them. It's something like adding oil between your hinges to make it more flexible. However, resulting loose character will reduce the ability of the film to act like a barrier. That is another problem. It might become more flexible, but the barrier properties reduce towards gases and vapors. The greatest obstacle for exploitation of this is the high water vapor permeability. They are not a good water vapor barrier. So edible packaging films and sausage casting are made from a blend of collagen and gluten. So you can make a combination of collagen and gluten if you want them to make it as an edible coating, which adds to the properties of the films. Another protein other than your wheat gluten is your corn protein. Corn protein, it's zein. It's the only protein that is commercially produced. It is characterized by its ability to form tough, glossy, that is shiny, hard, grease-proof coatings after evaporation of the aqueous alcoholic solvent. So once you remove the film that you get is going to be of better mechanical property. Now these have been used for pharmaceutical tablets and candies. They have been formed by spraying or dipping the product into aqueous ethyl alcohol, isopropyl alcohol solutions of zein. The solutions also contain the plasticizers which are approved. These plasticizers may be your glycerin, your propylene glycol, or acetaldehyde glycerides. Now, once these solvents are evaporated, you get these shiny, glossy, protective zine films, and that can be formed on the surface of the product. So, this is a very commercially useful edible coating. Another protein that is used is your milk protein. In milk proteins, casein is the major of the milk protein. Highly concentrated solutions of casein, they're firmly gelatinized, they're very closely cross-linked, and that is by using transglutaminase, and results in a film which has got good tensile strength, means good stretching property, elastic property. So this transglutaminase is a calcium-dependent enzyme that catalyzes the formation of covalent glutamyl lysyl cross-links. So once this enzyme helps in this cross-linkage, these films become insoluble in water, mercaptoethanol, and in guanidine hydrochloride. So pure caseinate films are attractive for use in food products because, number one, they're transparent, they're flexible in nature, and they have solubility in water. It's a table showing some of the commonly used proteins that are used as edible coatings and their main characteristics. Casein, collagen, conzine, gelatin, soy protein, and gluten. Casein we had already discussed. Collagen, it's extracted from animal connective tissue, good barrier against oxygen in solutes. They are hydrophilic, poor mechanical properties. Conzine, like we said, it's commercially available. Gelatin is produced from collagen by thermal denature. It's partially denatured collagen is gelatin. It's got amphiphilic behavior. Plasticized films show good mechanical properties. They're odorless and tasteless. But the problem is they have got poor water vapor barrier. Soy protein, the extracted from soybeans, poor mechanical strength but high water sensitivity. So not really used in the packaging. Wheat gluten, extracted from wheat. These again have got poor mechanical properties like we saw, but they are biocompatible, soluble in alcohol, and frequently they are cross-linked to give it more better properties. These are some of the commercially available edible chitosan and gelatin coatings. These are the names. In UK, you have this company of Agricoat Industries with the brand name of Semper Fresh. Nature Seal is another brand which is given out by the company of EcoScience, and Natural Shine 9000 in the US, and Prolong in London. So these are some of the commercially available chitosan and gelatin coatings that are available. This is one of the ways in which the films are casted. These edible coatings or films can be cast. You take these lines that you see here, those are the biopolymers are depicted as these curved lines. Plasticizers are depicted as these red dots, and the green triangle is the reinforcing agents like nanoparticles or essential oil. Any extra component you want to add along in the package, that is depicted by this green triangle. So in the first case, you'll mix these components together, homogenize them under very high speeds, degas them, and once you can add all these your other extracts. In this case, you've added this propolis extract is added. And once that is formed, it is cast the particular thickness that you want on a flat plate. Depending on the solvent is evaporated, can peel off that edible coating and get a film with propolis extract in this case, or whatever component you want to incorporate. This is a depiction of the way in which you can make an edible film using film casting. Now moving on to edible gums. So gums are polysaccharides themselves of natural origin, and they're utilized as thickeners and stabilizers or clarifying agents, gelling agents, or even as emulsifiers in the food sector. So they come from actually seed gums. You have mucilage gums, exudate gums. They come from different varieties of sources. Now these are biodegradable and sustainable alternative to your petrochemical based films and coatings. So the gum is an excellent option towards all these thermoplastics that you'll have. So natural plant gums based edible packaging, they will ensure this and the extension of shelf life of fresh and processed foods, mainly by reducing the microbial load and the oxidation process. So they are a good barrier against most of these. Polysaccharide based gum edible coatings, you can use your cellulose, agar, pectin, tarragum, locust bean gum, and gum arabic. All of these can be used as your gum based edible coatings. These are some of the methods in which you can coat your product with these gums. You have pan coating, drum coating them, fluidized bed coating, or spray coating these gums directly on this. All these methods will help ensure you get these gums which are edible. Now coming to the last part, which is the application. So I have mentioned just 5 applications in research in the papers that have been mentioned here. One is using chitosan. So they used this product, mango was used, they made a film out of that. These mangoes were kept in carton boxes that were covered with these chitosan films, and they were stored at 27 degrees centigrade, 65% relative humidity. The shelf life of the mangoes increased with no growth of fungus, and flavor and the color of the mangoes were also maintained. That gave positive results. Another is your wheat gluten. They had used this in refrigerated strawberries as a coating and a film. So there was a bilayer of wheat gluten along with lipid. They had combined this, and this was applied to refrigerated strawberries. And the results you got is they got firm, and there was firm strawberries, and there was a reduction in weight loss also. Further going, they again used chitosan in pork sausages as an active film. Green tea extracts were incorporated in the chitosan film. So in the edible film itself, you could incorporate whatever component you want. In this case, they incorporated green tea extract, and this was used to package your pork sausages stored at 4 degrees centigrade. They saw high inhibition of microbial growth and low count of yeast. Similarly, PLA was used in ready-to-use salads as a film. This PLA incorporated with allium species extract, that is your garlic extract. It was used for packaging ready-to-eat salads in a controlled atmosphere. So the films that contains 5% and 6% of this extract, it showed antimicrobial activity, mainly for fresh lettuce, and a decrease in the Enterobacter. So all this shows that there is a promising future for edible packages. Not only in the case that it helps in reducing the environmental pollution, but it also reduces cost in many cases. You're going to have biodegradable edible coatings, which will actually help you increase the quality and the shelf life of the product. I hope it was an interesting session. We'll see you all in the next session. Thank you so much.